So this lesson is going to be talking a little bit more about circuits. So to start off with, what I'd like you to do is take a look at these series of circuits. So this is the circuit that is going to be our home base, where we have one battery, so a power source wire and one light bulb in the form of the resistor, and this is glowing normally. So I'd like you to compare each of these circuits now with your partner to this normal circuit and and talk to your partner, is it glowing dimly, normally, or brightly, and explain why. So please, I'm going to have you stop the video right now and discuss that with your partner. All right, so hopefully what you came up with was that this one, I'm going to just put an arrow up to show that this one should actually glow more brightly because you've got two power sources, and so for that reason you've got a greater current flowing through there compared to this one. Now this one here has two resistors, so this one is going to glow less dim. It is going to glow dimly compared to this this normal circuit right here. This one here, assume that this is a switch. So for this one, because you have a switch, we're going to assume that there's no resistance in that switch. This should actually glow as normally to this one. So it would not be either dimmer or brighter. Now this key here, you know keys are usually made out of metal. That means that it is a conductor. We don't know whether or not the conductor is going to be having a little bit of resistance because different metals do have maybe slight different conductivity. So for this one, I'd be willing to accept any answer of glowing normally or glowing a little bit dimmer. And this one here, we would expect that this would glow normally to that one. So that's a good way to sort of review what we've been doing. Now, one of the things that that brings us to is that we've been building different circuits in our lab. So I'd like you to take some time and just sort of take a look at this circuit and compare it to this circuit. What's the difference? So please stop the video and ask your partner to decide what that is. All right, so the next part of figuring out what the difference is now I'm going to ask you to draw a circuit diagram for all of those. So please, again, stop the video and draw a circuit diagram. So hopefully you came up with circuit diagrams that look similar to this. Keep in mind, one of the things that a lot of students forget is that a circuit diagram has to be in a rectangular shape. So here we have a rectangular shape with two light sources, where here we have two rectangular shapes, as you notice that they're coming off of each other, again, with two light sources. So my next question is, which do you think will light brighter? Is it going to be this circuit, or is it going to be this circuit? And the answer is that this actually will be lighting brighter. Now, a lot of people are thrown off by that because they would expect this one to light brighter, glow brighter. But it actually doesn't. If you think about the electrons are moving through here. They then go through a resistor, so that energy that was an electrical energy gets transformed to light and thermal energy. So now you have less flow of electrons, because remember, those electrons were having their energy transferred to light and thermal energy, and then it goes through yet another resistor, so that at this point you have even less electrons flowing through, making these relatively dim. Compared to this one here, we have a flow of electrons. A lot of people sort of recognize, oh, okay, but now they're being split. But you notice over here, you don't have a resistor, so they're being split equally with no loss of electrons. They're just divided in half, and so here you've got the electrons losing that current being going through a resistor, and therefore you're losing some of that current because of the transfer of energy, and it then leaves. So in this case here, because you have no resistor reducing the flow, even though it's branched off, you actually have these light brighter. So let's go back to what some definitions are. this here we call a series circuit, where this one here is a parallel circuit. And the reason that it's parallel is you notice that you have two parallel wires coming through here, where here you've got a series of light bulbs right next to each other, hence why it's a series. A series of books, it's one book next after the next after the next, okay? So in terms of writing a definition for a series, you can get through the talk about the idea that you have a series of resistors, so one after the next, and they're all on one circuit, where here you've got them running through, electricity is running through different circuits. So let's see how we can actually do some calculations. So for these calculations, we in the past have always worked with single circuit. This is a calculation you should have no problem to do. Remember that Ohm's law says that current is dependent on voltage and resistance. So let's see what we have here. So in terms of voltage, in this problem we have a 12-volt battery, and we have one light bulb that has a resistance of 3 ohms. All right, and I am looking for the current. So I'm going to be using this formula, and I simply plug in my numbers. So 12 volts over 3 ohms to work out that we have a current of 4 amps. Okay, so that's the current with just one light bulb. Let's take a look now at a series circuit. From your reading, you should have seen that a series circuit needs to take into consideration all the different resistors that have been placed in that series. So in this case, our resistors are 3 light bulbs. So our resistance, our total resistance, has to do with light bulb 1. So let's put a nice equal sign here. There's light bulb 1. I'm going to call it resistor 1 because remember, a light bulb is a resistor. Light bulb 2 and light bulb 3. So the first light bulb has a resistance of 1 ohm. The second light bulb has a resistance of 2 ohms. And the third light bulb has a resistance of 3 ohms. This makes the total resistance be 1 plus 2 plus 3 being 6 ohms. And now we can just use our formula that we've used before. So we still know our volts to be 12-volt battery, and now our resistor is not 3 ohms, but it is 6 ohms. All right, so I plug it into my equation of I equals V over R, and with that, I then know that that's 12 volts over 6 ohms to be 2 amps of current flowing through. So do you notice here I have a greater resistance? My resistance is 6 versus here it's 3. So the greater the resistance, what do we figure about the current? Well, the current looks like it's getting from 4 to 2, which means that it is getting less. The less the current, which makes sense. If you've got a lot of things stopping those electrons to move through, less electrons are going to move through, and remember, current is the measurement of electrons flowing over time. So the greater the resistance, the less current. This is an inversely proportional sort of relationship. So let's add one more question, and this one is actually going to make one part be a little bit more difficult. So I'm going to stop the video, and I'm going to work through the first part of the problem and then work you through the last part. All right, so briefly going through this problem, you have a 9-volt battery, and you have a series where you have one light bulb that's 1 ohm and a second light bulb that's 2 ohms. I'm going to find the total resistance by adding those ohms together to get a resistance of 3 ohms. And then using Ohm's law, I equals V over R, I take 9 volts and divide it by 3 ohms to get a current of 3 amps. So that means that in the circuit we have 3 amps of current moving through. And this will continue to move through. So for the second question, find each bulb's voltage. Let's try with bulb that has the 1 ohm resistance. So firstly, let's identify of what we know. Firstly, we know that the resistance of this light bulb is 1 ohm, okay? I also know that the current flowing through there is 3 amps. So I know my RI value, that's 3 amps. What I don't know is my voltage. Now keep in mind, the voltage of a battery is not the voltage flowing through the light bulb. Those are two different things, all right? So let's figure out what we actually have. So in this case, V is my unknown. I again put it into my formula of, V over R. So in this case, V is my unknown, and let me rewrite that. So I is 3 amps, and V is my unknown, and my resistance is 1 ohm. So how do I solve this? I multiply 1 times 3, remember cross multiply, so my volts are 3 amps. 3 volts. So you notice that the volt between the battery is different than the volts that you see from the light bulb. That means that there was a difference of 3 a difference of 3 volts going in and out. So let's try that for the second bulb, the bulb that has 2 ohms. Again, same story. The resistance is 2 ohms. You have, again, still the 3 amps. The current is the same, and our voltage is our unknown. So we use the same formula of I equals V over R. And to place those numbers in there, we have 3 amps being the current. I have V being my unknown. 2R is my resistance, 2 omega. I multiply these together 3 times 2 to get my unknown. That works out to be 6 volts. All right, and so 6 volts, and you do notice one of Kirchhoff's laws is if you add this voltage together, you should get the voltage of your battery. So now I'd like you to try this on your own. Identify the voltage across each bulb and work through that. Best of luck.